Welcome to Sundar's lecture. In this lecture, we are going to see polar and rectangular form of an alternating quantity. Right? What are all the topics we have seen in the last class? See, we have taken phase and phase difference in the previous class, right? So we have seen what is lead phase, what is in phase, and what is the lag phase, and we have seen another topic with a different magnitude. With a different magnitude, if two phasors has a different magnitude and different phasors, and we can also draw this diagram by using the two circles, right? So if it is a single circle, then the maximum value of two phasors will be same, but with a different phase angle. That we have seen in the previous class, right? So in this class, and also we have seen how to draw the phasor diagrams. That is very important. The point to be noted, how you can draw the phasor diagram with respect to the given expressions or given AC quantity values, right? So next one, we have to see what is the polar and rectangular form of an alternating quantity. Before that, we need to understand certain things, then only you can mathematical things, then only you can easily understand this, what is rectangular form or what is the polar form of an alternating quantity, right? How we will draw the phasor diagram. See, this is the y-axis and this is the x-axis, right? This is the x-axis, right? So this is x-axis and this is the y-axis, and we would have drawn the phasor like this. Maybe you take this as I know. For example, I'm just saying, for example, if this is pi, yes, if this is pi, then what you do, you just you draw a line like this so that it becomes the right angle triangle. Now, my question, maybe I will take this part as ix, right? Ix, which means in x-axis, I have taken the value of I. I need to find what is this part and what is this part. Actually, an alternating quantity can be can be uh, divided into two different parts. One is x quantity parts, one is y quantity parts, and that is nothing but we are calling it as rectangular form of an alternating quantity. Okay, fine. I will explain one by one. So I am just considering this as the ix part, and this part, this is actually y part, right? This is in the y axis. So I'm just considering this part as iy part, Now what I need to do, I just need to write the sin pi and the cos pi values. Simply you can say that I need to draw, I need to write what is sin pi. What is sin pi? I am just writing here. What is sin pi? Sin pi, which is equal to, we know this one, right? Opposite side divided by adjacent side. Opposite side divided by adjacent side. Which is opposite side? This is pi, and then what is which the opposite to this angle, we will call it as opposite side. So this will be opposite side. This will be opposite side, and which is the hypotenuse side? Hypotenuse side will be this one, right? We know adjacent side will be the angle is here, so that this part will be adjacent side. We know this one. We know already these kind of things, right? We know already these kind of things. So this is the adjacent side, and which is the hypotenuse side? This one will be the hypotenuse side. So this is nothing but hypotenuse side. So sorry, I have written wrongly here. Anyhow, I will draw that. This is actually, what is this? What is sine? The sine will be opposite side by hypotenuse side, right? Hypotenuse side. So now you see, what is the value of hypotenuse side? It is I. What is the value of opposite side? It is Iy. What is the value of adjacent side? It is Ix. So if you want to write what is the sin pi, then sin pi will be is equal to what? What is the opposite side? It is Iy divided by, what is the hypotenuse side? This is I. That's all, right? So if I want to write for what is the value of Iy, I need to find what is Iy, right? So if I want to find Iy, then this I can be uh, taken to the left hand side. So I will get Iy will be equal to I sin pi. Sin pi. That's all, right? So you go for cos pi now. What is the value of cos pi? Cos pi. Cos pi will be is equal to adjacent side by hypotenuse side. Right? We know this one. Adjacent side by hypotenuse side. So what is the adjacent side? That is nothing but it is ix. So you write it as ix divided by what is hypotenuse side? We know that that is nothing but it is I. So you just write this as I. Right? So if I need ix, right? I need ix. So if I get ix, so if I get ix from here, so ix will be equal to, if I bring this I to left hand side, I will get I cos pi. That's all. Very simple, right? You can easily understand this one. So now you draw this diagram here. How will you get this diagram? See, if this is the y-axis, if this is the y-axis, and if this is the x-axis, and this is the value, that is I. So if I draw this one like this, if I draw like this, then I can simply write, if this is the value of I, if this is the value of I, then this value which is Iy, that is nothing but this is I sin theta, I sin pi. If this is pi, simply if this is pi, then this will be I cos pi. Simple, simple to write this value, right? So what is the angle here? What is the angle here? This will be always 90 degree. This will be, this is x coordinate, and this will be y coordinate. This will be x coordinate, y coordinate, and this is I cos theta, I sin theta. This is I. Simple. So we can write the given alternating quantity that can be divided into two values. That is, one is I cos theta, that is, and another one is I sin theta, which means this value can be written as, you see, in terms of mathematical things, we will get this j terms. What is j? What is j in mathematical terms? J can be written as square root of minus 1. We know this one. We already seen this one. Or we can write it as j square will be is equal to minus 1. Right? We have seen this one already. Right? And also, what is this j in terms of rotation? In terms of rotation, j can be written as 90 degree. Right? You see, this is 90 degree, right? J can be written as 90 degree. And how you can simply write this expression in terms, I will be equal to, I will be equal to I cos pi, I cos pi, just this one, I cos pi plus j I sin pi. Simple, right? Simply we can write like this, right? So an alternating quantity with a magnitude of I can be written as I cos pi plus j I sin pi. This is nothing but we are calling, writing an alternating quantity like this, we are calling it as rectangular form. Rectangular form. Simple, right? It is easy to understand. It is easy to understand, right? So next thing, polar form. What is polar form? Polar form. Next one. So simply you try to understand, or it's okay, fine. If you need to find what is the polar form, you just rewrite this expression. What is the rectangular form of writing the I value? A rectangular form, I is, which is equal to x plus j y. Simply, I'm just writing this I cos pi plus I sin pi. Everything I have taken it as I and it as y, right? So this is the rectangular form. We know this one, rectangular form. So if you want to find what is the polar form, you try to understand. We know these kind of things already. Anyhow, I try to give you an exact situation to understand this. So if you are having a right angle triangle, If you are having a right angle triangle like this, if you are having this, so this is the pi, this is the pi, and this is the value of I, maybe you take it as I, and this is the value of x, and this is the value of y, right? So if you are having a right angle triangle, by Pythagoras theorem, if you want to find what is this value, what is this value, and then what you need to do, what is the formula to write value of I can be written as square root of x square plus y square, right? This one we know, right? So if you want to get this value, then you can go for x square plus y square. Simple, simple to understand, right? So another term, if you want to go for tan pi now, so you just try to understand. If I want to write what is tan pi, what is the value of tan pi? Opposite side divided by adjacent side. I know this one, right? Opposite side divided by adjacent side, right? What is the opposite side here? Opposite side, which is nothing but it is y. What is the adjacent side? Adjacent side, which is nothing but this is x. So tan pi will be equal to y by x. And also, if you want to write, I will be equal to square root of x square plus y square, and pi will be equal to tan inverse of y by x. And if you want to write what is the, which means this is modulus value, you try to understand. By Pythagoras theorem, if you are writing, then this is the modulus value. And also you can write the I in terms of polar form. In terms of polar form, how you can write the value of I? So I will be equal to modulus of I and by an angle pi. So how will you find modulus of I? By using square root of x square plus y square. And what is pi value? Pi will be is equal to tan inverse of y by x. By this, I am just taking the right angle triangle here. See, it is very interesting, right? So an alternating quantity can be represented in two ways. One is the rectangular form, and this is nothing but the polar form. We are calling this as polar form, right? So you see, an alternating quantity can be represented in terms of rectangular form, or it can be represented in terms of polar forms. Simple to understand, right? So let us we take an example, an alternating quantity expression to find the rectangular form and the polar form now. So for that we will take a new page. See, we have taken an example. Find the value of an alternating quantity in terms of rectangular form and polar form. The expression is given. See, we have seen this expression already. And one thing I need to add with this um, derivation. See, everywhere you go, what is this I? This I will be always, a modulus value. This I will be always a modulus value, not a normal value. This is actually the modulus value, and always this I should be written in RMS values, not in the maximum values. I have not told you what is this I. Generally, we have taken this and we have derived the expression. But everywhere you go, if you are writing an expression in rectangular form, or we are writing an expression of an alternating quantity in the polar form, always we need to write this I in RMS values, not in the maximum values. We never use the maximum values at all. So you just try to understand. We always write the values in the RMS, right? So that one you have to understand. So we have taken an example here. I is equal to 20 sine of omega t plus 45 degree. So what is this one? How we can write this expression? So it is very simple, right? They have given you, that means Im which is equal to 20 amperes, and also the value of pi is given, right? The value of pi which is equal to 45 degree. Simply we can write like this. Okay, fine. Fine. If you want to write it in the polar form, I'm just taking the polar form first. So B polar form. So how can you write it in the, what is the polar form? Polar form can be written as I, which is equal to, that means this RMS value. This is actually RMS. You try to understand. I am just writing it as RMS value at an angle of pi, right? Both are given here. You need to find what is the RMS value. So it is simple, right? We know what is the IRMS. IRMS can be written as IM divided by root 2. And what is this value? 20 divided by root 2. That is nothing but you will get 14.14 amperes. That's all. Simply we can write this. So what is the final answer now? So I will be equal to, that means I will be equal to 14.14 at an angle of, what is pi? Pi is directly given here. Pi is directly given in the question. So what is that value? That is nothing but this is plus 45 degree. Try to understand. You have to write it as plus 45 degree since it is given in plus. If it is minus, then you put minus 45 degree here. So this is the polar form. This is the polar form, right? Polar form. And if you want to go for what is the rectangular form, so I will take A here, rectangular form, rectangular form. And what is the uh, rectangular form? This will be is equal to, I am just directly write modulus of I don't need to write RMS. You defaultly understand that this will be RMS value, uh, cos pi plus j modulus of I sin pi. That's all, right? We know modulus of I here. What is this value? This is nothing but modulus of I, which means RMS value. That is nothing but it is a 14.14. So I can directly write I will be equal to 14.14 cos of, what is pi value? What is pi? That is given, right? 45 degree. 45 degree plus j 14.14 sine of 45 degree. This is nothing but what? Rectangular form. This is nothing but rectangular form. Right? So we can write the alternating quantity expressions in two ways. One is polar form and one is rectangular form, right? You try to understand this one. It is very important to understand too. From here also you can easily find the values of a rectangular form. See, if it is given like this, if you want to find what is the rectangular form, it is very simple to understand. See, if they have given you like this 14.14 at an angle of 45, if it is given in the polar form, then you can directly write 14.14 cos of what is pi value, this is 45 degree plus j 14.14 and then sine 45 degree, right? It is very simple to write. But if you want to convert this into a polar form, that is also you can do by yourself. This is the value of I now. So this is how you need to represent an alternating quantity rectangular form and polar form. Thank you. We will see in the next class. Okay, fine. I have missed this one. We have written like this, right? I is equal to 14.14 cos 45 degree plus j 14.14 sin 45 degree. And further we can simplify this. So this one we have written it in numbers, but this one we have not written in numbers, right? So 14.14 at an angle of 45 degree, that is nothing but it is in polar form. And if you want to write it in the rectangular form, then I should be equal to, if we simplify this 14.14 cos 45 degree, if you are taking this one, this will be what? 9.99, maybe around, I will take it as 10 plus, and if you plus j is there, and 14.14 sine 45 degree. And what is the sine 45 degree? Sine 45, if you multiply 14.14 with sine 45 degree, then also you will get 10 amperes. This is how you need to write the expressions for rectangular form. This will be the final rectangular form, right? This is rectangular form. So this is 10 J 10 amps will be the rectangular form, and 14.14 at an angle of 45 degree in the polar form. And the general form will be 20 sine of omega t plus 45 degree is the general form. Thank you. We will see in the next class.